If you're ready to harness the power of your communications data, blast off with Nihilist today.
Hi, everyone. Welcome to Coding with Nihilist. In this live stream, we talk about APIs, programming languages, and helpful application for developers. And my name's Ram, and I'm a developer advocate at Nihilist.
Hi, I'm Blag, Silo developer advocate at Nihilist.
Awesome, Blag. How you been this week?
Allergies, as I told you, are getting worse today.
Oh, no.
Hear from my voice, my nose is like all stuffed. But it should happen in a couple of days.
Okay, well, hopefully everything clears up. We got the weekend ahead of us.
Yeah.
How about we jump in to today's topic? And I guess today's topic is inspired by a lot of the applications we build. We're always working with access tokens. And this is just something an application would give us to essentially an access token is something an application would give us to get access for a specific user. That's the use case we're looking at. And the idea behind this live stream is to consider different ways we can securely store third-party access tokens. For example, when you're building your application and you're building with Nihilist, you're going to be grabbing different access tokens for Nihilist for all the different users. So Nihilist's access token would be considered a third-party access token. And this is something you would want to store in your application for different use cases. So we're going to look at a demo or a code sample of how you can actually encrypt, decrypt access tokens. And we're going to jump into the code and just kind of walk through, and I'll explain it as I go so it makes more sense.
Cool.
So let me share my screen. And I guess the first place I want to start is from the Nihilist dashboard. So this is just a screenshot that I took. Anytime we connect an account to our Nihilist application, we're going to get an access token. And I know Blag and I have worked with these access tokens quite a bit while building applications. And it's very quick if you need to use the access token to make a call right away. But how about if you want to store this information for later? How would you go about doing that? Yeah. So that's really the question we're trying to answer today. How do we actually securely store these access tokens for future use? Cool. So I'm going to show you a quick demo before we look at the code, and then I'll kind of walk through what we're doing. I'm just going to kind of share the output section of the code. So we're doing a few things here. I'm just going to walk through it step by step. So in this section over here, let's go a little bit bigger. Yeah, the first piece of information we need is the encryption key. And the encryption key is normally something that you create very infrequently, and it's used across all of your different access tokens for a specific third-party account. Like, for example, all your Nihilist access tokens, you'd want to use one encryption key across all of those different accounts. And the encryption key is something that you store within your application state or with an environment variable. You can also store this in the database, but this is something that you can keep within the memory of your running application. And the next thing we're going to take a look at, which we already saw a screenshot of, this is your Nihilist access token. So here we're getting information back from an application, a third-party access token, and we want to store this information for future use. So if we have any async calls we want to do to Nihilist, or if we want to make any calls to Nihilist based off of a user's action or input, we want to store the access token for later. So I'm just logging it out for now. And I'll show you what this log looks like in a second before we dive into the code. And the next thing I'm doing is I'm just encrypting that information. So I'm taking the access token, I'm calling encrypt. We'll take a look at this function very soon. And then I have a value, an encrypted value that I can store in the database. And the point of this is you want to be able to encrypt credentials in your database so that if anyone gets access to your database, they can't really use any encrypted data because they're not able to decrypt it themselves. They need all these pieces of information to be able to decrypt the information. And then the last thing that we have is the decrypted value. So this is where you're going to do anytime your application needs to actually call the Nihilist API, it's going to decrypt the encrypted value. It's going to take the value from the database, it's going to decrypt it, and then you can go ahead and start making calls to the Nihilist API.
Yes, always important to have your information secure.
Yeah, this is something we definitely highlight in our blog post, that you should try your best to securely store this information within your application state, your environment variables, or as well within your database. So when I run this script that I just walked you through, I'm just going to show you all the different outputs so you get an idea of what we're going to be taking a look at in the actual code section of the encrypt.js. So here's the encryption key. And again, I mentioned the encryption key is something that you generate very infrequently. You don't need to generate for each user each time. You generally want to have one value for all the different users that are accessing the Nihilus API. So you can use the same encryption key across all the different Nihilus accounts. And here's the Nihilus access token. And this is something I showed you an example of the screenshot. This is what the access token looks like. This is what you get back from Nihilus. So you can start communicating with the Nihilus API for the individual user. And then we go ahead and we show the encrypted value to store. So this is what we're actually going to store in our database. So this is much larger. It's very hard to decipher. Someone that had this piece of information wouldn't be able to tell how to actually use it or how to decrypt it.
Mm-hmm.
And then we take the decrypted value to use, and this is equivalent to the Nihilus access token. So we took the encrypted value, we ran it through the decryption, and now we have a value that we can actually use to call the Nihilus API. So let's go ahead and take a look at the code to actually go through all of these different steps. So the first place I want to start is I'm just going to look at the generate encryption key.
Mm-hmm.
And what this is doing is it's just generating a random byte using the crypto library, which is available from Node or NPM. And I'm doing it based off of the encryption algorithm that I'm using. So I'm using, I think it's advanced encryption standard, 256 bits. And I'm generating an encryption key. And then I'm converting that to hexadecimal to use within the application or within the different functions. So once I have this encryption key, I can go ahead and decrypt the value or encrypt the value so that I can store it in my database. So let's take a look at that next. So in the encrypt function, we have a few things going on here. So I'm just going to try to walk us through them step by step. So first you take in the actual access token. And then we're going to create something called an initialization vector. And what this is every time we try to encrypt the same access token, it will always come back with a different result because the initialization vector is going to be randomized. So it's changing all the time you call this function, or each time you call this function. So with the initialization vector, we take that information and we actually pass it to crypto.create cipher.iv. So what this is doing is taking in the algorithm. So the first argument is the algorithm. The next argument just takes a buffer of the encryption key, which is in hexadecimal. So it's taking the hexadecimal value and as well as taking the initialization vector. So it's taking three pieces of information. From there, we actually go ahead and create a partial version of the encrypted data. So we do cipher.update and we pass in the access token. So what this does is it returns a partially encrypted version of the access token, and it stores that information for us. And what we do is we have one more step to do where we actually complete the encryption by doing buffer.concat, and we take the partially encrypted data, and we as well get the final version of the encryption. So these two pieces of information is the actual encrypted data from the actual access token.
Nice.
So what we pass back as encrypted is we take the initialization vector. So that's the first part of the encrypted data. We put a semicolon in front or after that, and then we pass in the encrypted data. So there are two pieces of information we need. Anytime we need to decrypt this information, we need the initialization vector and we need the encrypted data.
Cool.
So now that we've taken a look at this, I guess one thing I didn't highlight here is the encrypted key is something that we already generated ahead of time. So if I scroll down, you can see that the encryption key is generated on line 57. This is generated before we actually call these functions. So it's available to those functions.
Cool.
And as well, one other thing I didn't mention is the IV length. This actually depends on the encryption algorithm. So in our case, we're using AES 256. that's going to require an initialization vector length of 16. So it really depends on the algorithm that we're using. We just need to pass in the specific lengths of the different encryption key and as well the initialization vector length that we need. So now that we've gone through how to encrypt the data, let's take a look at how we can actually decrypt the data. Before we jump to that, one thing to keep in mind is the encrypted data is what you want to store in your database. So this is only information that your database will see. It's what your database will use, but it's not actually what your application is going to use. So your application is going to use the decrypted version of that data. So let's take a look at what that looks like. So first, we're taking the encrypted access token. And as I mentioned, it has two parts to it. So it has the initialization vector and the encrypted text. So we actually split that up into the different parts. And then we grab the initialization vector separately. And we as well grab the encrypted text or the encrypted access token separately as well as two different variables. So we initialize crypto as, again, we do crypto.create decipher IV. And we pass in the algorithm. And then as well, we buffer the hexadecimal value of our encryption key. So one thing I want to emphasize here is the encryption key is using in both the encryption and decryption side of things. So you always need to store this information within your application state. So it's probably recommended, or it's most recommended, to be an environment variable that's accessible throughout your application. So we take the encryption key and as well we take the initialization vector. And then we generate a partially decrypted data. So this is our first step. We decipher.update. We call decipher.update, take the encrypted text, and we have partially encrypted data. And the final step is we just concatenate the partially encrypted data or partially decrypted data with decipher.final. So this creates a hexadecimal version of the decrypted data. And all we have to do is decrypted.toString to return that information. And this is when you would actually take that access token and you start using it in your application or calling the Nihilus API. So just to show you that one more time, because we've walked through all the different code pieces, encryption key is what we want to create normally 1 or 2 times or very infrequently. And this is what we're going to use on both the encryption and decryption of the access token. So it's used throughout the application. And then the Nihilus access token is an access token that you'd receive from a third-party application like Nihilus, and you'd want to store this securely so that you can use it throughout the journey of your user. Anytime your user needs it, you want to be able to grab this information, decrypt that value, and be able to communicate with the Nihilus API. And then encrypted value to store is the value that we want to store in the database. So this is the information we're going to store in our database, and it's not really human readable or even usable by the application. So what we need to do is anytime we want to communicate with the Nihilus API, we're going to get the encrypted data from the database, and we're going to decrypt it to use within our application.
Cool. Yeah, so pretty much
so those, go ahead.
it goes encrypted to the database, and every time we need to use it, we just want to grab it, decrypt it, and use it. But it remains encrypted on the database. So it's secure.
Yeah, so this adds another layer of security so that if for any reason your database is compromised or this value is accessed, it actually doesn't make any sense to someone. They wouldn't know how to use it because they don't have the encryption key, and they wouldn't know how to actually decrypt the value.
Yes, exactly.
Yeah, just another thing before we wrap up here, please go ahead and like and subscribe. We'd love to hear from you. Any feedback, any thoughts, any ideas for future videos. I can see Blag trying to get your attention.
Yeah.
Please, we'd love to hear from you, and we look forward to doing more of these live streams.
Yeah, totally.
And as well, live streams every Wednesday and Friday. So we try to stick to the schedule. I know summer's a little busy in other areas as well. But we're always excited to have live streams. So try to catch us on Wednesday and Friday at 2 p.m.
Yeah. And yeah, also follow us on social. We're on Twitter, LinkedIn, TikTok, and kind of everywhere we're Nihilus. So just go there, follow us, let us know, send us a message, and please be a guest of our show. We haven't got any host yet, any guest yet, sorry. So we would like to have one on our show.
Awesome. That's all I got for today.
Cool. Thanks, Ram. That was pretty interesting.
Awesome.
It's always important to have information secured so that it doesn't get stolen or misused. But that was pretty awesome.
Awesome. Cool. All right.
Great.
I will see you all next week. Bye, everyone. Thanks, Blag.
Bye, Ram.